Okay, so over here we have a DRV question. Okay, I just want you to take some time to read in case you have forgotten. Just look, we are concerned mainly with part 1 only. Okay, part 1. Okay, so if you have read the question already, you will understand that we are choosing two balls out of three possible types, of which one of them is n, so it's a not specified number. Okay, and there's also a game matrix here. There's some sort of payout that if you fulfill certain conditions based on the balls that you draw, you will get different amount of money. Now, when I hear the idea of two balls, draw two balls, and find out the possible payout, I'm always thinking to myself, draw a table of outcome, okay, where on the left hand side is the first ball that I draw, and the right hand side is the second ball. And because they belong to either 1, 2, or 3 type, the type of ball with the number 1, 2, or 3, every time they intersect is just one possible outcome, all these possible outcomes. Okay, and in this table, the outcome that I'm putting in is the payout, so it follows the rule of the question given here. You can just refer back to C. Alright, so because of that, and this DRV question is all about the table, x and the px equals x. It's table over here. Okay, so I have filled in the unique cases based on all these numbers that I see in my table over here. Alright, all I'm interested in is finding out the probability of each. Once I do that, my life is easy now. Then this is a very easy DRV question. Okay, now yes, and there seems to be a bit of a challenge with finding the probability. So here I can offer you two suggestions to solve it. Okay, since we're drawing two balls, we can have some fraction times another fraction, where each of these fraction denotes the probability of drawing that particular ball. But you have to note this one thing, okay? What does times mean? In probability, recall that you have times versus plus, correct? Plus is or, correct? When I say the probability of A or B, let's say I have, something like this. Okay, probability of A plus probability of B. I'm saying that either could happen, right? Then this plus really means or here. So when you do times, what you're saying is, and then, okay, that is what you're saying. So it means, what's the probability of drawing this first ball, and then probability of drawing the other ball? Okay, so it's sequential. Something happens and then something happens next. Okay, I'll elaborate more on this later. Now the other method you can use is PNC over here. So you just have one probability, and there's a probability of success over probability of all your cases. Now in this question, the easier one to choose would be this, and it's more intuitive. In fact, PNC may be prone to a careless mistake here. So I recommend doing this. But you just have to note, the idea you're going for if you do times is, I choose one ball and then I choose another without replacement. Okay, even though that is not seen in the question. Okay, they just say they take two balls at random simultaneously, isn't it? So please note again, if you are choosing to use this method, something times something, you are asserting that you're taking one event, the first event, and then the second event. Okay, so you have to bear in mind. The method still works, but you just need to take note, something in here, the denominator will change. Okay, so we're going with this. We're going with the method on the left. Now let us try here. Okay, I would first like to know the probability of, what's the lowest lying fruit? These two cases. Okay, they both give me a pair of 6, and you realize this is a 3-1, and then this is a 1-3. Okay, so let me go and plus them together, because remember we want an OR, right? Because either OR will give me the score of 6, which is what I want. So the probability I'm going to do OR, which is just to add them up. It is not both happening. You can't simultaneously have 1-3 and 3-1 at the same time. Okay, so here's the calculation. See if you can understand this. Now how do I get this over here? Why did I do times 2? Because I observed that 1, 3 and 3, 1, you know, actually the probability does not change. The order just changes, right? Instead of A times B, you have the other one, right? Plus B times A. Now, since the probability of B is the same and A is the same, you can just say it's like this. Something like this. Okay, so that's what I'm going for here. Otherwise, you can be hardworking and you can just write out both individually. Okay, I can spot this shortcut, so I'm using it. All right, so if I want a 1, 3, let's say, let me do this. Okay, so the first round I'm going to draw a 1. Now observe up here. How many balls do I have in one? I have 3. How many balls do I have in total? I've counted it to be n plus 5. So the probability is simply 3 over n plus 5, as I have over here. When I put a times, I'm telling myself, and then, okay, good. So I have already drawn 1 ball. The remaining ball should have decreased. Okay, and then I want to go for 3. So I see that there are 2 balls. So the probability is 2 over n plus 4. You simplify it to get this over here. Get the idea? Okay. What we're going to do next, we're just going to repeat this for all the other cases. Okay, so I have 6 here. The probability is as such. Okay, repeat this idea multiple times over. You can pause the video. This is for the next case. I'm doing 3, 2, 2, 1. So basically, I'm handling all the cases here. Okay, I observe again. 3, 2 and 2, 3, you know, they're the same, so I can just times 2 to one of them. 2, 1 and 1, 2 is, you know, the same, so I can just times 2 to each of them. So I calculate them one by one. Okay, plus them together and just handle the calculation. Okay, finally the last one for your negative ones. Okay, same idea again. There's the same idea. You will observe that the subsequent number has decreased because when I draw one ball from the same group, well, the total number has reduced, but then also the total number of the balls of the same type has reduced. So I'm going to go -1 to that. You realize I -1 to everything, all -1. Okay, and I should get this. Okay, and this is my table over here. Now, finally, I link that to the question. They say expected to receive is 8. Expected money to receive is 8. I can understand that. I just want to sort out this. Why did they put largest value unless there's a range? There might be multiple answers. Then I'm suspecting a quadratic over here. Okay, cool. So that's what we're going to do. Okay, just note that I've made a change to this one over here. There's no change in the answer. It's just a translation error. So earlier on the calculation was as such, 8 plus n minus 1. I copied it wrongly, so this is the appropriate correction. Okay, just a translation error. Okay, so from here we have the table, and recall that DRV, since the question asks, expected to receive money. If you expect to receive money from this game, this just means that, okay, let's make sense of this information. They're just saying that is greater than 0, right? You expect to get a positive money rather than negative, which is you lose money. Okay, so all we need is this, right? Find the EX. Can you find EX given the DRV table? Of course you can, right? So likewise, you just go and times over and sum them up together. Okay, I've done the work for you, and with a bit of steps, you'll get to this. Now we want here. So how do we do that? If you realize, we can just throw away the denominator, because we know that n is a positive number, right? Number of balls is positive, therefore n is greater or equals to 0. So we know that the denominator greater or equals to 0. So I can times both sides by denominator. Sign will not change, I'm sure of that. And from here we can go and solve. Okay, so this is the range that holds, but of course remember that I said that n must be greater or equals to 0, so if we merge them together, you should get this. Okay, so long as n, which is the number of balls labeled as 2, is between 0 to 8.5, then we have a game where we can expect to get money on average. And then you're going to ask me, but Mr. Pang, can you have 8.5 balls? And yeah, of course you can't. So since we also know that n must be a whole number, then we have to define it too as such. Okay, so back to the question. We want to show that the largest value of n is 8. And since we have a range here, all we have to do is take the upper range, isn't it? So okay, so feel free to rewatch this video and have a recap of the method over here, what we have done. Okay, essentially the first step is to get your x column. The next step is to get your px equals to x column. This is intuitive if you identify that this is a DRV question. Okay, you always need your table. So then we go x, then we go the px equals to x. And then from there, just apply your basic formula of ex. And in this case, this is unique to this question. From here onwards, okay, unique, they merged it with inequality. Okay, so that's why this question is worth 5 marks. I would say the difficulty rating is 2.5. Okay, on a scale of 1 to 3, difficulty is 2.5. It's definitely above average. Okay, so I wish you good luck with this question. Please try on your own.